All right, folks, let's go ahead and get started. Good morning, good afternoon, and good evening, depending on where you're joining us from in the world today or where you're watching this replay from. My name is Len Thompson, and I am Broadcom's Mainframe Division Community Manager. I want to welcome you to today's webcast. Before I hand you off to our presenters today, just a couple of things I need to cover. First, if you have questions along the way, and we always hope that you do, please use the questions box on the lower right-hand side of your screen, right under the control panel. We'll get through as many of those as we can during our time together today. If for some reason we can't get through everything, if we run out of time, or if the team needs to do some research to get you a better answer, I will make sure that I capture all the information that I can so they can follow up with you. We are recording today's session. The replay will be available sometime later, probably tomorrow morning. That's why your lines are muted, because of the recording. And the last thing from me is we want to make sure that you find this session valuable. So there will be a short survey that will pop up at the end of the session. If you could give us some feedback, I know Dana, John, and I would all really appreciate that. That's it for me. So I'm going to hand you off to Dana Boudreau, who's going to kick us off. Take it away, Dana.
Hello, everyone. Welcome to the webinar, Resolving ZOS ABENDS Using Modern Tools. This is a first for us, a first of what I hope to be other webinars, focused on, quite frankly, solving what are problems that you may have with modern tools for the mainframe. It's been a tradition in the mainframe for many years of sharing amongst each other, sharing what works and what we've learned. And this series of webinars is targeted to that kind of activity. So our goal is to provide these webinars as well as workshops and interaction through a growing developer community. Your feedback is appreciated. As Len said, certainly John and I are interested in feedback on this session, but I'm equally or even more interested in your point of view on other topics that might be of interest. Or if you feel that you have a topic that might be of interest, we could talk about that as well. Our presenter today is John Sales. Jonathan Sales is his name on the screen here. John has been doing education in mainframe for quite a while. He's a mainframe developer in his past. He has a great deal of experience with not only traditional mainframe development, but using modern tools. And I'm sure you'll find his sessions entertaining. John's a real person and is often known as the geek for the guitar geek. So I want to welcome John here today and kick it off, John. I'll pass it to you.
Yeah, thanks, man. Notice that if you parse what Dana just said, he didn't say educational, he said entertaining. So we hope to do both, but you never know. So let's see. Let me share my screen and we'll get going because we want to move along and there's no point in you just looking at what I am. So can you see? Can you see what's going on? Everything.
Yeah, we can see, John, but I'm going to ask you to go full screen into presentation
Yeah,
mode.
I'm going to do that. Yeah, I just want to make sure that it got off my face. Okay.
Yep.
So essentially, I joined Broadcom as a consultant, I don't know, a few months ago, and was very, very fortunate to work with a group of people you see on this screen here, Veet and Lukash and Scott, who's not here, unfortunately, but he's a brilliant mainframe intertest guy, my boss, Dana, and all these guys. Without these guys, nothing would have happened at all. We would not be here. Standard disclaimer, you'll get this if you get the slides. And by the way, you might want these slides because at least I think they're pretty useful. Let me get this. So I just want to get sure. Okay. Okay, sorry. I was trying to get rid of the little toolbar that was getting rid of my view. So some caveats. In the session, I have built out, I don't know, a couple dozen use cases of ABENDS. In order to get through them, they are very, very, very small. Okay? They're very small. And because of that, you'll learn directly about, we get this because of that. It will be cause and effect easily seen. That's not to imply that that you will not have a lot more work to do when you get an ABEND in production with one of these giant beasts that you see over here on the right. That's an actual production program from one of my consulting gigs long ago where I purloined the code on my way out. Doing a root cause analysis of this kind of stuff is measured in days to weeks, but at least after the session today, you'll understand more about the ABEND world. And it's important to know that today's session is for COBOL people, not sysprogs. You all know this, sysprogs. Okay. All the examples are in COBOL. The compiler was 6.3. And all the work I'm doing, in other words, AKA the modern tools, are VS Code and Code4Z and other extensions. You won't see ISPF, you won't see any of the Eclipse-based tools. It's VS Code and Code4Z. So the agenda is, I thought about this last night until like 2, and I realized that instead of trying to work from the slides backwards into the tools, I thought it'd be better to just essentially do tool work and then bump into problems, show you what they are, etc. So we're going to take a whirlwind tour of modern tools because, it'd be great if, as an audience, you could let Dana and Len know how many of you have experience with the modern tools of of VS Code and Code4Z or something like that. So VS Code essentially. So I mean, it'll help to know what percentage of you actually have this versus it's all Greek. So we're going to cover ABENDS, the 2 phases of ABENDS, and then using the modern tools. But in fact, this bullet down the bottom will go up at the top. If you want a copy of the programs that I've got, I would call them open source. And the JCL that runs it open source as well. Most of the things I have here are just IGY, CL, Cobol G procs that you have installed, so you can just run them as soon as you get the code. Let them know in the chat and the slides as well. The slides are really important for you going on from this. So real quickly, I'm an ex-IBMer, but I'm very, very fortunate to be working at Broadcom at age 71. I can't believe they actually hired me. I have a lot of experience, almost all of which has got to do, has been in the graphical world as well as 3270 tech world. Okay, so let's see, and I am not technical. You just need to ask the people who have helped me along my way, and also if I was technical, why am I still working at 71 years old? So as Dana said, I'm an old guitar player from New Jersey. That's what I am, an old guitar player from New Jersey. That's all, And the point I make with that is not to be self-deprecating, but to let you know that if I can do it, you can do it. If I'm able to handle these things, you can, and that's a lot of the value I bring to companies like Broadcom is that when I was 25 years old, Nixon was being pardoned by Gerald Ford. And if you go back that far, so tools you'll see today are these tools, and what'll be real interesting is seeing all of those, in the workflow of doing batch and resolving ABENDS. A lot of people tend to think of VS Code and Zoe Explorer as sort of editors. They're editor tools. That they're editors for programs and such. Well, you won't see much of that. What you'll see is a ton of real-time work. Doing the kinds of things that production support people do, and that you do during testing. Right? Speaking of VS Code Code4Z, you'll see that it doesn't have a whole lot in common with ISPF. And what I'm going to do is hopefully get you through, the learning curve here so that you won't freak out at all of this stuff. It's really nothing all that different. It looks different on the surface, but how many ways are there to skin a cat? There really are not. So what we'll see today, and this is essentially the workflow throughout, is that we're going to launch VS Code and then go over it real briefly and then start working with programs, submitting batch programs that ABEND, and then looking at the ABENDs and figuring out what went wrong. Okay, it is important to know that this is not VS Code training. I know that Broadcom is thinking about, I shouldn't say planning, is thinking about providing a class specific to ISPF developers and their experience base. You can contact Broadcom people for that if you're interested, but this is not supposed to be training. Don't think that, you know, as I run through this stuff, you'll be able to do much with it. So, launching VS Code. I have a private VS Code install. Notice how quickly it came up. The response time is insane compared to, well, it's comparable at least to 3270. And so the productivity that you can expect will be genuinely far better than what you may be used to with other tools. Yeah, so enough of that. And I'm going to close that up now. I am going to use for this session, though, probably more like a VS Code instance that your company will set up for you based on scripts. So thanks to Veet and others, scripts have been written that actually run. And hold on a second. Scripts and sorry, go back to this again. Where we go. Good one. Scripts that will set up the environment for you, including configuration files, launch files, and such. So think of these scripts as nothing more than contemporary logon procs. And if you think about contemporary, you know, TSL logon procs, and if you think of a logon proc, did you write the logon proc? No. The systems programmers wrote the logon procs, and you know, and you didn't have to know all of the gorp that goes in those C lists and maybe rexes, I don't know, but nothing that you've had to deal with, and yet that did the exact same thing. It set up your development environment, giving you access to libraries that you should have access to and keeping you out of places that you shouldn't be in. So this particular instance has on the far left what's called the activity bar. Think of this as the ISPF primary menu whoop, turned on its side. That's all. So I'm looking at what's called the Zoe Explorer, which gives me access to data sets, jobs, USS stuff. I can look into Endeavor. I can use ABEND Analyzer, which unfortunately I'm not set up to do today. The machine that I'm on is a ZD&T machine, which is actually one of the machines that could be available to you in your classes, getting pre-configured and all of that with a ZD&T instance so that it's all yours to work with and play with. Extensions are essentially add-ins or third-party tools that you can install if you're on your own, like I mentioned before, private instance, or if you're in this public instance, you will be able, you know, you'll see what's installed and what's configured. And these are just, they show up here, and I know that they are not, can we say, this is not the workflow that you're used to on the mainframe. On the mainframe, everything is hidden from you using ISPF and stuff's behind the scenes. And even if you're using Eclipse tools, most of the time shops will have spent gobs of time configuring this. In this open source VS Code world, you will see all of these third parties, and depending on your shop, you may have the ability to access others, which you can search for in what's called a marketplace. So you can think of these things as apps. I'm actually old enough that I don't even own an iPhone, and I don't care to, but I know because my wife does all about these apps. She has hundreds of them, I think, or dozens. So think of these as apps, and they can be seen from the extensions icon on your activity bar. We'll do running and debugging in a bit. And there's also very slick and efficient access to Git source controls as well as Endeavor, you know, and searching for files and exploring things. And then there's a menu that allows you to do additional stuff. So consider this ISPF primary menu stacked vertically. That's it. So what I'm going to do initially is I'm going to go into some work. Right now I have nothing in my data sets, so I'm going to do something that I'm going to ask you, what is it that you know about this kind of thing? I'm going to do an ISPF, wait for it, 3.4 search for data sets that begin with my ID, which is cut 002. So that particular search will take a second because of ZD&T. If I was using a real mainframe, it would already have popped. So here are all of the files that are available to me. I can make this search much more granular if I wanted to. I could go to search, and I could take this custo2 thing and say I want to see only the learn.star datasets go. And this will then reconfigure just like 3.4 does, and I can take these data sets, and if I want, I can actually make them favorites so that they appear in a favorites bar. Very similar to ref lists or some of the IDZ tools that you may have seen in using Eclipse. But I'm going to go back to the whole cust02 stack because I want to see everything. And I also want to make sure you understand that there really is very little that is different. In other words, what I'm trying to show you is if an old guitar player from New Jersey can learn these tools, so can you. So here's the alphabetized version of all these files. And in the jobs, I can do the same thing right now. I see no jobs, so I'll go to the search for jobs and I'll search for cust002. And here are jobs that are currently available. And this is just like going to SDSF or any of your Jez, Jez toolings. Go into here and see what's up. Look at all the messages, etc. Simple. And I want you to know, besides simple, how incredibly fast this is. The response time again is just remarkable. Just remarkable. So let's see. What I wanted to do was essentially go through a series of batch jobs that will, as you see here, bomb, B-O-M-B, bomb, and we'll start with U4038. Now, a U4038 is, let's go take a look at the slides for a second. So in the slides, you'll see a lot of information as background. And I'll come back to some of this, but I really want you to see it in context. There are lots of tables that will show you exactly what the common ABENDS are and how to get them. So let's take a look at these 4038s. So 4038 ABENDS essentially happen when you have contradictions between your specifications for file, records, block sizes, things like reading past end of file, reading before opening files, etc. These used to be called System 0001 or SOC1 and a bunch of other MVS return codes. But in the interim between the time I was working and the time back in the 80s and 90s, and now, IBM decided to handle all of these I/O problems with language environment. And that returns a generic return code, which you're saying, I don't like generic return codes, I get it. But in fact, we'll see that it gives a great deal of information afterwards. So in these slides, again, I've got all kinds of stuff about these particular ones that I don't have time to get into today because I want you to see the tools. All right, so I want you to see the tools. So let's take a look at this first problem. And we're going to execute this job in batch. Assume this just happened in production last night. Note that like many of the modern tools, instead of using entirely typing and equal this and equal that, the context menus are propagated with the common types of actions that you would want to do on a JCL data set. So I'm going to go here, submit the job. It says, are you sure, yes or no? Okay, I guess. And then behind the scenes, sorry, the job has been submitted, and you'll notice that I have a link to the job, which I can just click on and take a look at when it finishes. So this job abended with, as I mentioned, a 4038. So I'm going to refresh it and have a look at what's in this 4038 and see if we can figure out from there what happened and why, because that's the key. So interestingly, even though I don't have any dump handling here, LE tells me exactly what went wrong. So this is what's nice about LE versus these MVS return codes, is that we get a lot more information back about the problem itself. Now, this doesn't happen all the time, but I picked this first one so you can see that, you know, at its best, Ellie will give you a whole bunch of information that you'll need to, you know, to address the problem. So let's go here, take a look at this payroll file. It's a payroll, right? Yeah, payroll file. Good. So let's take a look at the payroll file. And what I'm going to do is show its attributes. Again, more of these very fast and very convenient modern tools. It is in fact LRECL 80, which is not unknown to mainframe programmers. Now I'll go into the code itself, which is in one of these libraries. And we'll have a look at the program. And right now it says 59. Okay, so that's why. So you can see how quickly you can get to the problem of these simple 4038 errors by using the, you know, a combination of, you know, the learning that you've done, perhaps these slides to help you figure out what's wrong, and then of course the tools to get you around inside of the working environment quickly. So what I'm going to do now is we'll see one more 4038 error, then we're going to move on to more important or common and difficult things. Now, what I want to do is I want to comment out all of these lines. I don't see a comment out line here, so I'm going to go to the command palette and toggle it. And so I have all kinds of command palette things, and that's basically like =6 for the editor. So actually, it's like the ISPF editor command line. So I'm going to go to the command line again, and I'm going to say get rid of all of these comments. So I can do that kind of work very easily and quickly. It's nice, you know, it's the kind of thing that you have to do, although this is contrived, I get it. So, I mean, most of you would just go in here and say, no, not 59, 80, I get that. But I wanted to show you the, you know, some of these extra tools that are neat. So now we're going to save our work, and we're going to need to recompile and run the program, but I think that's part of the JCL here. So 4038, submit the job, and have a look at the job when it finishes. Sometimes these finish faster than other times on ZDNT. Okay, went up EOJ. Very nice. Now, what we're going to do next is we're going to now take a look at the debugger for this, because I need you to see that it's not only the tools that you can use, you know, during editing and batch jobs, but I want you to see how we'll invoke intertest as a debugger. So intertest is an extension that is installed along with Code for Z, and maybe they call it debugger for mainframe here, but it's really intertest behind the scenes. And we're going to use the batch version of it today. Feel free, you know, I assume Vite is and anybody else who's on, you know, in the background is getting is busy typing away and giving everyone the correct thing to say about what I'm about to show you and all these extensions, because I'm 71 and I don't know the vocabulary yet. But you can see that the tools are just tools. So having said that, the tools are just tools, but in order to invoke a debugger under VS Code, we're going to need a different process where we're going to go and execute JCL that sets up intertest for its own debugging, which means it's going to write all of the literals, and essentially they're called symbols, which are basically literals, variables, and you know, and the code itself, and it's going to write all of the various tree-controlled elements of the program into a symbolic file. So we're going to end up using a slightly varied JCL from what we just saw, and this varied JCL is going to have a number of steps to load up the debugger with what's necessary for us to have a debugging session under VS Code. Now you're saying, well, who made this stuff, John? You know, who created all this? Well, who did this on the mainframe? Your sysprogs. You know, when you set up the environment to do, I don't care what it is, not Expediter or file or IBM's debugger, someone had to write this JCL. So here's the JCL, and if we look at it one more time, the only thing we need to do in this JCL is say, I want to debug this program, and it's coming from this library. Done deal. In other words, cobol.sysin. No big deal, right? Just this program, this library. Those of you that are used to using procs of 2, 3, 4, 500 lines will look at this and laugh. This is not complicated. This is just basically your execute a proc and override things so that we can use the Intratest libraries. So once I compile this program again, which is again the same concept of just running it and creating a load module, the load module in a specific library that's just specific to my environment. It'll have any number of different kinds of access points in your work. But the job ran and it produced reports that show all about these symbols and messages, but its return code's 0, so I'm good to go. Now, I have a load module that should be here in public.load library. There it is. So we got a load module ready to go. And let's go take a look at the tool off of my primary option menu, AKA activity bar, called the Run and Debug Tools. So the Run and Debug Tools, again, look nothing like what you've realized, but let's see how hard this is. Here is a list of launch files or launch configurations. Where did they come from? Well, in this case, my buddy Veet helped me write this. And in fact, he did 99% of the work, and I filled in one of the blanks. Let's have a look at this. The launch file is written in a language called JSON, which is nothing but a markup language, meaning it's like XML. And if you want to go back further, meaning it's like HTML. For those of you who can handle, looking at 6-page nested ifs or SQL subselects, this is nothing. It's just a different format for named pairs. And in this JSON file, which is again nothing but a markup language that says, for my launch configuration, I want you to have one called U4038. It's going to be a batch launch. The program name had better be U4038 or we have a problem. Here is where that Intratest symbol lib comes from. And by the way, again, these will be different in your shop depending on what you're using for debugger, with these tools. But very simple. For me, it was after V took me through this, and then look. So here's my user ID, because I'm going to actually log into the mainframe again in order to use this. And here's where the converted JCL comes from. Whoa, converted JCL. Did not mention that. So let's go to the converted JCL. Debug 438. So we need JCL that provides not syslib, we're done with that kind of stuff, but all of the DD cards. Now, nicely enough and appropriately enough, the work that was done here in the JSON file, let's go back to this quickly, doesn't have areas for you to allocate or to set up DD cards for your input and output files, because that'd be ridiculous. They have, I know in production you'd have dozens of them. I know, I did that kind of work. It's nuts. It's why 6th graders deliver newspapers and don't do production COBOL work. But here's JCL. That is standard JCL, and all I've done is I've thrown into the standard JCL sort of a header that says run the debugger, execute this program, use this launch profile, and here are a couple of other libraries that were set up by that compile for the debugger. Nothing. Once you understand this stuff from the standpoint of I did this all the time in the mainframe, then it doesn't look like Greek anymore. Apologies to any of you from Greece. So this is a payroll file, and there's an input file here, and there's sysout and all of that. So I'm going to name this debug file to pick up the Intratest definitions, and of course, all of these DD cards. Disp equal new, disp equal share, blah, 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 disp equal mod, etc. So I go back to my bugger, and I'm going to take a look at this one more time to make sure you're clear that that's what this means. Converted JCL says, I want you to pick up this member and utilize the DD cards when the program runs. So I selected this particular launch out of this entire JSON configuration. Each of the launches that were separated by these brackets show up here. So I'll grab here, and then I'll go and hit the start, and it asks for my mainframe password, and it needs that because all I presented here was my username. So let's see, type correctly. I love PCs. Yes, you may. I'm not seeing. No, I don't want you to save my password. So again, this is running against the ZDNT box, so any slowness really can be blamed on that. And now we're in the land of debugging. So how hard was that? Let's go back to our steps and just make sure you understand that this is what I did. I edited the program, I submitted the run JCL, it bombed as expected, confirmed it. I set up for the intertest debugging, which means essentially I compiled and linked intertest libraries, and then I referenced in this launch configuration the library that will have my DD cards, so that when I opened this file, it found that a particular DD card for payroll, which happened to be here. Note that the tight integration with the stuff, note the speed with which this stuff happens, and all of the screen real estate, I mean, this is really nice. So I think I'm going to close this and go back to this, and I'm going to continue on my debugging process. And go back. So let's force an ABEND here. So basically, I ran through the program to go back. And you know what? I'm going to force an ABEND in my SOC 4 because I see that it's 11:35, and as usual with John's presentations, tempus fugit. So I'm going to go to a SOC 4 because I think that'll be more interesting, and it's the kind of thing that you are going to have difficulty with if you don't know the following. So a SOC 4 is essentially a situation where an address in one of these machine code operands has pointed outside of your protected address space. Now, an address space is just an area that confines your code. Make sure you don't mess up anybody else's run, and make sure they don't mess up yours. It's a gigantic address space, but in fact, you could go beyond it by having as part of your assembler code an operand with an address in the operand that points beyond the actual boundaries of the address space, right? So this slide, again, should be useful to help you figure out what these kinds of things mean. What are these kinds of things? I'll show you this in a minute. This is the actual list of a COBOL program called SOC 4, and you'll see, the actual instructions, or as they call them in the Z principles of operation, which is the Bible of ZOS, opcode and the operands that they run against. So the values aren't known at runtime, especially because I'm going to move these things in via variables, and the addresses will be whatever they are. And in fact, in the case of SOC 4, it's going to end up bouncing outside of the address space and causing an OC4. So let's watch that, see how that works. So let's take a look at the program. Not much to that, as you'll see. Except in this case, the first thing I'm doing is I'm actually saying I have a table. This table occurs 4 times. How often does that happen in your world? Never. 400 times, yes, never 4. However, in this case, in order to make things clear, I have simplified. And I also have a ton of use cases here, which again, if you grab the code, you're welcome to take a look at these results by running that simple proc that shows you exactly what happened. And this is what I've left out, use case 5. And what I'm doing is I'm moving a really, really, really big number to the index, way beyond 4. And then I'm saying, just display it. Go ahead, just display it. Now the display will then, of course, force the assembler instruction to go get this the value at this address, which is now beyond the address space, and SOC4, or so we think. Let's find out. So we go into our batch JCL, and we'll run our SOC4 job, which is just one of these Cobuck LGs that runs this. I don't even think there are output files. No, this is just all code, which is how most of these SOC4s happen. They don't happen in output files. They happen because of logic errors. So let's take a look at what happened here. And we got a SOC4. And let's see, did LE help us out? No, it did not. I've got some displays here, but really we have no idea why this happened. Whereas LE for those 4038s told us a ton of information, didn't it? So for here, we need to debug. So let's go and do a debug. And let's do our JCL2. And we're going to remember the steps. We're going to compile and provide the environment with the correct intertest symbolic file entries for this program called SOC4, S0C4. We just submitted this job. It's not small, but looks like ZD&T has eaten its Wheaties today, so it finished pretty quickly. Again, I might want to check these out. Veet was very specific that I should check out this report, but I'm going to throw caution to the wind and say, because I got zeros here, we're good to go. And I know you do that too, because that's the world of mainframe programming. I was telling Veet last night that a 4 return code from a compiler is like jaywalking. It is not a thing to stop your development for. Okay, so let's debug it. Well, let's just take a look at what's in here. So this is that same thing we saw earlier, the profile name, the program itself, and the fact that we're going to run intertest against this SC04. So we go to our intertest debugger environment. Let's see if we have a SOC4 in here. Do we have one in here? Oh, we do. I'll tell you what we're gonna do. We're not gonna just so you can. I'm not gonna take the time to do this. It's getting late, and I want to do SOC7s. I was going to, as part of this demo, just show you that to create another one of these entries to produce another configuration. Whereas you might think, oh, look at this GORP. I have to be like 30 years old to understand this. No, it's not that hard. You just take an example that's a model, copy and paste it, and then just modify what? The name, the program name, and the JCL member name. All right, so let's go and grab that SOC4 debug launch, and let's launch it. I think it's going to ask us again for, no, okay, so this time it didn't ask us for our user ID password, our password, because it still remembered it. Isn't that nice? And here we are. So it loaded the program into intertest into the environment, and this is the current instruction. If I click this, well, I'm not going to give you an intertest demo, but this is the next sequential instruction. So current instruction is what the debug people call this type of element. When I was taking COBOL classes at the Travelers, they called this the next sequential instruction, meaning if I click this, it will execute this instruction and go to the next sequential instruction and then flag that. So I like to think of these as the NSIs. Now, what can I see in terms of debugger technology? I can select this. I can go to here. I can look at all of the examples of this. And what I'm doing now is just pointing out that all of the tools that you would have during development are here during debugging. Mini maps of the actual code itself. Sorry. The ability to find references throughout and see them and use those as ways to get around. It's very nice. So the things that you do after you've done your development, all the things that are debugging are just the opposite side of the same coin of understanding the semantics of your application, and that utilizes the tools that you'll use when you're doing your development. So, for example, let me go into program here. Oh, this is JCL. Sorry, program here, and show you that kind of thing. So this is a program that is not production, scale, but I can use this control flow and see all of the semantics of the actual operations in COBOL, not assembler this time, but in COBOL, as I scoot through to the various paragraphs and find out how I could get there, answering the very famous question, the most important question when you're dealing with an ABEND: how did I get here? How did I get here? So all of these tools will be available, and I'll show you just a second. This was an edit, but if I open this program up, you'll see the same thing, and you'll see that this is so trivial. I don't even have paragraphs, but if I did, they'd all show up here. So just let you know that all of this is possible. So I'm gonna keep marching. Now let's watch this. Boom. So the display statement blew on this tab index because it's too large. Now, what I could do, of course, at this point is I could take a look at the value in it, go back to my my actual table itself, see that the table itself is defined, that was a reference, is defined as occurs for, and decide what to do. Now, I hardwired this, obviously, this 99999. This could have come in from a DB2 table, could have come in from linkage, whatever. The value that I got onto this index is obviously outside the address space, so there's that. So we got a SOC4, and once we got a SOC4, we're going to now do that root cause analysis. And then what I did just then was just kill the process, the debugger, so I can keep on going. Root cause analysis, and that's going to take much longer in production. And my doing a root cause analysis for these trivial programs nets you nothing. Next. Now I assume there are questions. So what I'm going to do is one very quick SOC 7 problem, and then I'm going to stop. And what you'll be able to do at this point in the presentation is decide if you want. See, this is this information that's all available in the slides. Is to decide if you want maybe another one of these. What you can think of as a poor man's TED Talks for tech, or if you want to. Isn't this great? I used to do this during my demos. I just found a typo in the slides, and I got rid of it, and I hit Control S and save. Wouldn't it be nice to do that in COBOL? Anyway, decide by talking to the guys at Broadcom whether or not they want to offer more of these, or another one of these with a deeper dive into the other ABENDS. Anyway, SOC 7s happen only on numeric variables, and they happen when the principle of operations, that ZPOP, executes an instruction that expects a certain format in hex of a certain variable definition type. And when it doesn't find that format, if it's radically off, it blows. It happens with the SOC 7. It says essentially we have a numeric data exception. Now, what's kind of obvious if you know anything about, if you've ever turned hex on, in your source files in ISPF, you see these things all the time. These are the EBCDIC fields, or the hex values, binary values, for different display types. What's not as obvious is what happens with pack fields. So pack fields are very sensitive to this because the trailing nibble, I call this nibble in the previous slide iteration, but it's actually, so it's actually this last thing. It has to be a C, D, or F. At one point I read E, but if it's not a C, D, or F in hex, Fs are 1, 1, 1, 1, 1, 1, 1. So if it doesn't find that, then you get these OCC ABENDS, OC7 ABENDS, and lots of information on what causes these ABENDS, and then a little bit on what's called numcheck. So I mentioned that the directives and compiler directives and runtime directives can actually mess with what is produced for these ABENDS, and of course they will. And of course your shop will have different APARs and PTFs supplied in the compiler, so you will need to find out, from your sysprog, what are the COBOL compiler options, although you could simply do this. Let's see. You can. I'll compile another. I'll do the OC7 one here. And where's my JCL for this? I'll just show you this certain thing that will show you exactly the compiler directives in case you're interested. So this is this program that should OC7 one way or the other, and it didn't. Okay, so this it didn't OC7. Let's find out. Well, let's take a look at the. So I must have something. Yeah. So I've obviously gotten rid of everything that would cause OC7s there, and we'll get to that in a minute. But I want to show you this COBOL sysprint, which has all of the directives at the top of the listing. You probably didn't pay much attention to it ever. Why should you? But now you know that if you're actually looking at for OC7s, this may be why I didn't get it this time. Or if you're looking for OC4s, SS range. OC4s will have SS range or no SS range directives. And if you look into the slides, it talks about what numcheck and SS range do in order to to handle these things. And when I say handle these things, they'll actually insert or inject code into the load module to do numeric checking throughout the program. And you're thinking, well, that's cool. Why not just make that the default? Well, because these additional machine instructions are tre expansivo. You know, when you're processing it, yeah, I remember I was working at, I was doing a demo for Social Security in the US, and a woman who ran a project team came up to me afterwards and talked about their performance problems. And she said, we have to get through our single batch that runs, you know, every hour. In less than 7 minutes, it processes 150 million records in 7 minutes. Bah. She said, can what you're showing me handle that? I think the answer was probably no. But you see why numcheck is not just simply going to be considered default in production. Certainly development and tests, not in production. All right. So let's go back to my program, because what I saw isn't exactly what I wanted to show you. I wanted to show you an actual ABEND. So let's go back and my program. Okay. Okay. So this was interesting to me. One of the things the slides shows is that when you have is that along with all the other information on the OC7s, there are use cases that I docked here for you guys that will, OC7 or not, depending on the format of the statement. For example, all of these math verbs will blow. Let me just uncomment this. This math verb did not blow because of the giving instruction. And the giving instruction essentially just said, whatever is in this field, which at the time of the run had invalid data, just stuff the result of the multiply into it. I don't care what's in it. Just move it in. You know, I don't care. Just throw it in there. Now, because of that, as you saw when I ran it, it did an OC7. All right, okay, fine. Actually, this is going to OC7, so I'm going to save this and let's run this one more time. I hope you're getting something out of how easy and almost fun this is to do, you know, with these tools. It's quite stunning. You know, when I was doing other tools like the Eclipse tools, I thought they were just, you know, the end all and be all. And I'm so used to this stuff now, and the learning curve was not hard. It's just a different set of vectors, of mouse vectors. That's all it is, a different set of mouse vectors. Nice too. And the response time is insane. So got an OC7 this time because I did this and because field packed is not initialized. Now you say, well, I'll always initialize fields. Okay, probably. If you don't, if you're on, let's just say for yucks, if you're on production support one night and someone didn't initialize a packed field, that's what will happen upon this statement. Okay, but not happen upon this math statement because of the giving instruction. Okay, so now let's walk through this and see what's going on here. When I do a compile into the intertest libraries. So submit the job, to compile my SOC 7 program into the InterTest libraries. Let's see how long this takes. Drum roll, please. I'm not a very good drummer. Back to this. Okay, good. Now we'll take, we'll take a look at this. All I've done here again is this. I've added the name of the program in here, and that's it. Now you will have to have your DD statements. And as I said early on, I don't mean to imply that what I'm doing here is anything like what you'll do for your root cause analysis on production support. But because of all these idiosyncrasies in these things, I'm hoping that you'll get something out of the details here in these slides, as well as the programs themselves. So back to here. And what are we saying? Yeah. Debug. Do we have a SOC 7? We have a SOC 7 launch configuration, all set to go, pointing correctly. So in theory, go here and run. So setting up and running and submitting the JCL to run InterTest in the foreground, and depending on when ZD&T is ready, there we go. So we'll pop down here and we'll take a look at some of these fields, huh? All right, so our field packed is in an invalid format. Right away, I see that InterTest to the rescue. So I don't even need to have read all this stuff that John gave me, because InterTest said, oh, wow, NG, as we used to say in New Jersey back in the 60s, NG, no good. So when I do my next sequential instruction execution, boom, because this field in an invalid format, and I'm just going to go real quickly into this, attempted to add packed one of the operands that was at this address in the address space, but it did not have the correct nibble in the OC7. Okay, it's 11:55. I know you guys have questions. I'm gonna kill it for now and see if you have anything that I can help you with. I don't know. So back to here, and stop sharing my screen. And if you have questions, let's go for it. Hopefully you've been able, I'm looking at Veet and Dana, and they're sitting back going, what was that? It just washed over us. All right, so questions.
Thanks, John. The only question we have so far is the Broadcom debugger updating generic settings for run and debug, which comes with VS Code as standard? I'm not sure if you're the one to answer that.
No, well, I probably should be, but it's over to Veet for this one. So Veet, the question was, is the debugger updating the launch JSON scripts in the VS Code standard? Somebody in the audience obviously knows VS Code like the back of their hand. Veet?
I don't understand the question. I'm sorry.
All right. So whoever asked that question, if you could give us a little bit more detail, that would be appreciated.
So maybe in the meantime, you know, what I can say that InterTest is set up on the backend as a server to which the extension is connecting to, and the launch JSON that John was showing is instructions that tell the extension running inside VS Code how to connect to InterTest on the background and what job to submit. Essentially, that's it. But maybe if we get more details, I'll be happy to elaborate more.
All right. Here's another question. Do you have something installed to get the job name submitted as clickable at the bottom right message?
No. Okay, let me show you quickly. So that this, even I can answer, whoa, no way. So let's go back to this. He's going, yeah, I showed you this just this morning, John. So essentially, when you submit a job, you know, any old job that pops up here, when you go to the Explorer and you submit a job, it will give you the yes, no, and then on the bottom right, you'll see the job name. Now, I happened to close this a couple times, and Veet said, hey, John, look at the very bottom right. Notifications. Whoa. Okay, so very bottom right, for those of you who are at my level of VS Code expertise, here are all those jobs.
And maybe, John, if you click on the like caret sign on one of those messages to expand them, there will be a little more details. Yeah, if you hover over it and move to the right, to the right, there is like a caret sign.
Yeah, the side didn't help a
So
lot.
yeah, so this well, it doesn't have like any useful information here, like for the developer, because the message is sufficient. But here it shows you that this message originates from Zoe Explorer. So in Zoe, what John is using here is Zoe Explorer on the left side in the dataset view. When he right clicks to submit, Zoe Explorer, after it submits the job, notifies in the UI the user with the job number, so that it can be easily found by clicking on it. Yeah. So it comes from Zoe Explorer.
Or if you screw up and you close it automatically, you go over here to the far right in the bottom, and there they all are from this session. Thank you, Veet. Veet is very good at this stuff, isn't he? Other questions?
Yes, can we load code for Z from the standard library?
What is a standard library?
I think you mean, well, they probably mean this, right? Will it show up in extensions? Or maybe not, I don't know.
Maybe we'll get some clarification. Next one, is run and debug part of VS Code, and the intertest extension tells run and debug what to do?
Yeah, it's actually the other way around. So the run and debug sections are standard part of Visual Studio Code, and the UI and experience is the same for all programming languages. So what the debugger for mainframe extension does is it implements the API that VS Code provides, so that you can debug COBOL programs, whether it's batch or kicks, in the same way you would debug a JavaScript application in VS Code.
Yeah, this was kicks as well. I didn't have time to do kicks, and besides, if you're an IMS shop guy like I used to be, I was so angry at how much kicks there was, and never in the IMS example. So I went with batch. Everybody's got batch. Works great. Other questions?
We are actually at the top of the hour, so we do have to shut this down to respect everyone's time. I appreciate everyone's time today. Again, there is a survey that's going to pop up when I hit close. There is a spot in there where you can ask additional questions. We would love some feedback on today's session. Any and all feedback is welcome. John, thank you very much. Veet and Dana, you as well. And to everyone who joined us, we really appreciate your time. And as Dana said at the start, we're going to hopefully do more sessions in this vein. So keep an eye out in the community for those as well. Have a great day, everybody.
Take care, everyone. Thanks for your time today. Bye-bye.